Okay, the essential question for today's lesson, how can we use the greatest common factor and the zero product property together to solve equations? Okay, remember, set your notebooks up in Cornell style to take your notes. All right, so the first one, solve 2x equals 0. Okay, so what do we do to solve this one? Divide by 2 on both sides. And so x is equal to 0. So then if we plug it in, 2 times 0, does that equal 0? Yes, it does. So you get 0 equal to 0. So that works. Okay, that's leading us into what the zero product property means. So now let's take a look at this one. We have xy equals 0. Okay, so x times y is equal to 0. So what can we say about x and y? The only way you can get 0 when you multiply, one of those numbers has to be a 0. You have to do a number times 0 to get 0 as your answer. So one of those has to be 0. Either the x is 0, because 0 times y would equal 0, right? Or the y is equal to 0, because if I have x times 0, that's also going to equal 0. That is the idea behind the zero product property. Okay, so this is not the zero product property itself. This is the converse of it. Okay, so if you have a is equal to 0 or b is equal to 0, when you multiply them together, you're going to get 0 for an answer. So it works the other way around as well. If I have a times b equal to 0, then one of those must be the 0 part. Either the a is the 0 part or the b is the 0 part. But one of them has to be 0. That is the zero product property. All right, so we're going to use that idea to help us solve an equation like x plus 2 times x minus 3. So we're multiplying those two quantities together. So if I'm multiplying two things together based on the zero product property, then one of them must be 0. So I'm taking this expression times this expression. I'm multiplying those two together. When I multiply, they equal 0. So that means either the x plus 2 part is equal to 0, or the x minus 3 is equal to 0. Then you solve those two equations. That'll give you your possible solutions. So I minus 2 on both sides. X equals negative 2. Or I add 3 to both sides. X is equal to 3. Now we're going to check it. So I'll do the x equals negative 2 first. You must use one at a time. You can't do both at the same time. Only pick one and check it. So my x is going to be negative 2 first. So I plug it in. Negative 2 plus 2 times negative 2 minus 3. And I'm checking to see that it equals 0. What is negative 2 plus 2? 0. And negative 2 minus 3. So does 0 times negative 5, what's that equal? 0. Okay, so the negative 2 works. Now let's check our x equals 3. Plug it in. So we get 3 plus 2 and 3 minus 3 equal to 0. What is 3 plus 2? Times, what is 3 minus 3? Okay, we're checking to see that that equals 0. What is 5 times 0? 0. 0 does equal 0, so the 3 also works. So this is your final solution. You must show this middle step, okay? That x plus 2 equals 0 or x minus 3 equals 0, and then solve each of those equations. Okay, next. We're going to factor using the greatest common factor. Okay, so we're going to factor using the greatest common factor. Let's talk real quick about what a factor is. So if you have a number like 24 and you need to give me the factors. Factors are numbers that you multiply together to get that number. So what numbers can I multiply together to get 24? 6 times 4? 8 times 3, 12 times 2, 24 times 1. Okay, that's all of them. So when I'm asking for the greatest common factor, I'm asking if I have another number, I should have done another one, like 36. Okay, so 36 is 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. So greatest common factor, I've got all the factors listed. We're looking for which number is on both lists the largest number possible. So let's see, both of them have a 4, both of them have 6s, okay, both of them have 12s. Okay, what is the greatest factor they have in common? 12. Okay, so that's the greatest common factor. So now we're going to use it to rewrite these kinds of expressions. Okay. In the past, remember when we did distributive property? Okay, you have something times all the stuff in parentheses, and you had to multiply it by everything, right? Now we're doing it in reverse. I've given you the answer to that problem. You need to rewrite it. What did I multiply with? Okay, so what two parts was I multiplying to get 6x cubed y minus 15x squared y cubed? So let's look at the numbers first. What do the numbers have in common? Their greatest common factor. A 3. Okay, I can divide that by 3. I can divide that by 3. So 3 is what they have in common. So that goes on the outside. If I take the 3 out, what's left? 2. If I take the 3 out, what's left? 5. Okay, so I just did the numbers first. I usually don't do that, but just for this first time. Now we look at the variables. Let's look at the x's. How many x's do we have in this first one? 3. How many x's do we have in the second one? 2. How much do they have in common? There's 3 here. There's 2 there. So they both have at least 2 x's. So they have 2 x's in common. So on the outside, you're going to write x squared. If I take out an x squared here, what do I have left? 1x. If I take out the x squared here, what do I have left? Okay, I took out all the x squareds. Now let's look at the y's. Okay, so there's how many here? How many here? How many do they have in common? 1 y in common is on the outside. Do I have anything here? Nope. How about at the end? Y squared at the end. Okay, so nothing in that first spot and the y squared in the second. So that is our solution. So if you looked at this and did distributive property and multiplied that way, you should get what you started with. Let's try the next one. I have one more example together, and then you guys get some practice. So 24w to the third, y to the fifth, plus 16w for y to the second. So usually when I do these, I do the entire greatest common factor first, and then I do the inside all at once. So let's start with the numbers. What does the 24 and the 16 have in common? 4. Okay, they can both be divided by 4. They can both be divided by 8. Is there anything bigger than 8? Is 8 the biggest? 8's the biggest. So I put an 8 on the outside. Now let's look at the w's. How many w's do they have in common? So how do I write it? How many y's do I have in common? How do I write it? Y to the second. Now I'm going to simplify. So I took an 8 out here. So divide by 8. What do I have left? Any w's left? How many y's do we have? Okay. Divide by the 8. What do I have left over here? W's? Y's? That's your answer. This one has an interesting thing that happens. What do they have in common? 4. What else? Look at the variables. Well, I've already got the numbers. They both have, oh yeah, and 1 W. Okay, I hear ones, I'm thinking numbers. Okay, so they have 1 W in common. What's left over in the first spot? Okay, so 4W2 minus What's left here? Okay. So I hear a lot of ones. So you said nothing. I hear some zeros now. Okay, let's think. Hold on. Let's think about the reverse. Remember, this would be multiply. So if I multiply this way, is that going to equal 16w to the third? Okay. If I multiply 4w times whatever we put here, what number is going to give me a 4w? 1. There's a 1 there. So you have to multiply 4w times 1 to get 4w. So if you take everything out of the expression, then you have a 1 left because you have to multiply by 1. Okay? The last idea is just putting those two concepts together. We're going to solve by finding the greatest common factor first. So if I look at this expression, what do they have in common?
1.
Just one x. Okay, so that's 3x plus 2 equal to 0. So first thing you have to do is factor. So any factoring, this is always the first step, the greatest common factor. Greatest common factor is always the first step when factoring. Now I have x times this expression here. Okay. Now we're going to use the zero product property and solve. Okay, so first factor, find GCF. Second, zero product property. Okay, so that's where you take the first one, x equal to 0, and then the second one, 3x plus 2 equal to 0. And then you solve. So this would be x equals negative 2/3. So these are your two possible solutions. Okay, so that's the third. You then solve both. Okay, now here's some practice problems similar to the ones that we had done in class. So do these on the left side of your notebook, and we'll check them in class next time.